Parallax, stellar parallax in the concave Earth. Is there stellar parallax? Is there really? I've been just starting to get into this stellar parallax concept, and I have a problem with it. In theory, yes, I understand how parallax works, but stellar parallax? Let's find out what it is all about. Let's play this clip of this chubby guy who doesn't understand that we live inside the Earth try to explain a parsec, which is the distance 3.26 light years, and which is derived from measuring stellar parallax.
Consider how the Earth travels around the Sun in its orbit. At one point in the year, it's on one side of the Sun, and then 6 months later, the Earth has traveled to the opposite point in its orbit. From our perspective here on Earth, a nearby star will appear to move back and forth. A tiny little bit in the background universe.
Back and forth. Remember that. Back and forth.
You can get the same effect by holding up your thumb, staring down your arm, and then opening and closing your eyes. See how your thumb is moving back and forth compared to the background scene?
Yeah, I do that.
This is known as parallax.
Back and forth.
The foreground object moves compared to a more distant background.
Yeah.
By measuring the changing angles from the observer to the star
that makes sense.
in the background universe, you can calculate the distance.
I see. So that's how you calculate the distance of stars. By the parallax, the back and forth angles.
Imagine a right angle triangle. The bottom of the triangle is the distance from the Earth to the Sun, also known as an astronomical unit. The side of the triangle is the distance from the Sun to the star, and then there's the angle required to make the star appear to move 1 arc second in the sky. The sky is broken up into 360 degrees. Each degree is broken up into 60 arc minutes, and there are 60 arc seconds in an arc minute.
So 1 arc second is 3,600.
1/3600th
of the sky.
For example, the closest star in the sky, Proxima Centauri, has a parallax measurement of 0.77233 arc seconds. That's how far it shifts in the sky when the Earth shifts by position by 1 astronomical unit.
Shifts.
If you put this into the calculation...
So Proxima Centauri, you should be able to see satellite imagery or telescopic imagery of Proxima Centauri going back and forth. Back and forth. Now there's another thing I was discovering. They call it proper motion. Proper motion of stars. It just shows the stars moving that distance within the perceived parallax, but I have a problem with this because I don't see any back and forth motion of stars. Here's one called Barnard star. Barnard star is one of the stars that has the largest known proper motion. Barnard star. So this star moves the most, but it's not going back and forth. It's not going back and forth. Barnard star is not going back and forth. Where'd it go? Look. Okay. That's just looping the animation. It's going from like year to year. I find a better animation of that. It's just moving. It's a free floater in the heaven bowl, the celestial ocean. Okay, most of these stars are pretty much stationary. They're fixed within the celestial sphere. But there's some free floaters that are moving. They're not going back and forth though. Look at this. It's going from, see the years? Where's the back and forth? It's going linear. It's traversing linearly. Is that a word? Linearly? I don't see any. So if you like, I typed in proper stellar parallax. When you type in stellar parallax in Google Images, all you get are illustrations. You don't get any live, actual imagery. All you get is theoretical bullshit about stellar parallax. You don't have any images. I don't see any, unless maybe somebody can find some and show me some. But I don't see any real imagery of back and forth, of oscillation from 6 months on one, unquote, one side and 6 months on the other side as the Earth revolves around the sun. I don't see it. Tell me, please. Show me. All I see here are illustrations and theory of what stellar parallax is. But in reality, we don't see the oscillation. We don't see the back and forth. We see proper motion. We see movement of these stars. Here's one that's kind of loopy like that. It's doing a little loop as it traverses. It never goes back. Okay, this comes from year to year. This traversing is probably due to the magnetic influence that the sun plays on it from year to year. But it's just a floaty. It's a free floaty in the heaven bowl. It's a free floaty in the heaven bowl. Proxima Centauri, the closest star. See guys, stars are tiny. They're created by multi-bubble sonoluminescence. They're very small and they're very close to us. And most of them are pretty much fixed. There's a few free floaters, but the free floaters are not indicating oscillating back and forth parallax. To my knowledge, show me where, somebody please show me some imagery of a back and forth oscillation within a 6-month extreme. So 1 full year. Show me this oscillation. Real live telescopic footage of oscillating stars. I don't see it. I just see the proper motion of the free floaters. That's all I see. Imagine all this bullshit, all this crap that people believe. Look at all the time and the hours spent on investigating this bullshit. It's just theory. Yeah, parallax is understandable. I mean, you hold your thumb up, you can see your thumb against the background at different placements, but that's not happening with the stars. To my knowledge, initially, I just started looking into this, but maybe you guys can help me. Show me some live footage of oscillating back and forth movement, oscillating in 1 year's time. Barnard star, Proxima Centauri, they're showing movement, but they're not showing oscillation on an annual basis. I don't see it.